This module teaches you about toxic substances in pufferfish, lycopene, which is an antioxidant in tomatoes and other fruits, and sunscreen. In your assignment this week, you will have to show a detailed mechanism of the Diels-Alder reaction, which is just one step of the reaction to synthesize tetrodotoxin, which is in the Japanese pufferfish. When one eats the fish that has a trace amount of this toxin, this can result in paralysis and eventual death. And it is your job this week to determine the exact mechanism on how to go forward in the Diels-Alder reaction, as well as how to go backwards, and how you could possibly enhance this reaction. Let us discuss delocalization and conjugation. When p orbitals are at adjacent carbons, these p orbitals can overlap, and they can form what's called a pi bond. And in the pi bond, the electrons are delocalized. Then, when the electronic density is spread out over the pi cloud, this lowers the energy of the molecule and makes it more stable. So in this example, the p electrons are in these p orbitals at these adjacent carbons. And these electrons are overlapping in these clouds. There are two pi bonds in dienes. In order to determine whether the pi bonds are conjugated and therefore the pi electrons delocalized, one has to look at the particular constellation of these pi bonds. For example, in 1,3-butadiene, the pi bonds are all in adjacent carbons, and therefore the molecular orbital overlap is possible between the electrons. However, if you look at 1,4-pentadiene, this is an isolated diene, and conjugation is not possible because here there's an interruption of the pi cloud on this carbon. Here are some dienes that may be of interest to you. Isoprene, for example, is given off in a plant when they are under stress. It increases the plant's immune system and tolerance towards heat stress. Or lycopene is found in tomatoes and other fruits, and it is considered very healthy and an antioxidant. Conjugation also is related to absorbance of light. The more the molecule is conjugated, the higher the absorbance. In this example, there are only two pi bonds and therefore absorb at 217 nanometers. Add one more pi bond, the absorbance increases. Add several more pi bonds, the absorbance can eventually shift from the UV to the visible. This concept is important in sunscreens. For example, these two sunscreens are currently used in commercial products, and they absorb in the region of the UV spectrum that is dangerous to the skin and can cause skin cancer. Electronic overlap and conjugation also plays a role in organic reactions, such as the Diels-Alder reaction. The Diels-Alder reaction is an addition reaction between two molecules, a dienophile and a diene. And it makes a 6-membered ring with a new pi bond and two new sigma bonds. The way how this connectivity occurs is that the dienophile reacts with a diene by making a new bond here. This breaks the double bond and makes a new double bond here. And that breaks this double bond and makes a new single bond here. So overall you have one pi bond and two sigma bonds. This reaction typically requires heat. Here are some examples of the Diels-Alder reaction. The dienophile reacting with a diene, making 3 new bonds. I'd like to point out that the diene is typically more reactive towards the dienophile when it is substituted with an electron-donating group. In this case, the diene is substituted with 2 methyl groups. And when there's an electron-donating group on the diene, that pushes electronic density towards these 2 pi bonds. And that causes the dienophile to be more attracted to the diene. On the other hand, the dienophile is electron poor, and it is substituted with withdrawing groups, such as this aldehyde or this ester. Here you can see a couple of examples of a classic dienophile that is substituted with electron withdrawing groups: aldehyde, ketone, ester, and hydrides. Now, why are these groups electron withdrawing? They are very electronegative, and they therefore pull electron density away from the pi bond. And this makes the dienophile more reactive to the diene. Sometimes when reactions are occurring in the presence of heat, the reverse can happen as well in the presence of heat, such as in the retro-Diels-Alder reaction, in which basically everything that was made in the Diels-Alder reaction is now going into the opposite direction, such as in this dicyclopentadiene, in which where the pi bond that was formed in the Diels-Alder forward reaction now gets broken again, as well as the sigma bond gets broken, and this sigma bond that was made gets broken, leading to these two original starting materials. And now it's time to become conjugated, overlap, and have fun with your assignment.